In this question, we see that a parallelogram is determined by certain vectors, and we want to determine the other vectors in the parallelogram and also to calculate the magnitudes of those vectors. So the vectors that determine the parallelogram itself are A, negative 3, 2, and OA, negative 3, 2, and OC, 5, negative 1. So what we're going to do is let this be point A and let this be point C. From there, we can see that the parallelogram OABC, there has to be a consistent rotation, and so the fourth point must be out here somewhere. Well, it's pretty easy to calculate. We know that it's going to have to be 2, 1, because whatever we do to get from 0, 0 out to negative 3, 2 has to be the same journey that we would take to go from the point 5, negative 1 out to B. So what we can do is say, starting at the point 5, negative 1, if we were to add negative 3 to the x component and then add 2 to the y component, we would end up at 2, 1. In other words, add negative 3 to the x component here to give us a 2, and then add 2 to the y component here to give us a 1. And there we go. So now the vector OB is 2, 1. And so it becomes pretty easy for us to determine what the vector AB would be. We simply subtract the x and y coordinates of A from B, subtract backwards like they say. And with BC, we simply subtract backwards as well. And we get that these are the vectors of all of the sides of this parallelogram. Now, in order to determine the magnitudes of those sides, we simply use the magnitude of a vector formula, which is basically the distance formula from grade 10. So the vector OA's magnitude is negative 3 squared plus 2 squared, quantity square rooted, which is 13. The magnitude of AB, we simply figure out that the vector AB is 5, negative 1, and then we get the magnitude of that vector, which is root 26. And similarly, the vector BC has a magnitude of root 13, and the vector CO has a magnitude of root 26, which is what we would expect, the opposite sides of a parallelogram having the same magnitude.